Lesson number 16, demo number 2. Recall that the cube root of 64 is 4. Said another way, the cube root of 4 cubed is 4. That's saying exactly the same thing because we know the 4 cubed is equal to 64. This fact should help us simplify the cube root of x cubed. So there's something happening here. There's a cube root and there's a cube, and those two things are in a very real sense opposites of each other. They undo each other. Cubing something and then immediately cube rooting that same thing will get you right back to where you started. So in this case, we start with the number 4, we cube it, 64, and then we cube root it and we get right back to the number 4. And so in general, if you want to do the cube root of x cubed, you will just get x. Number 2, what does the 4th root of x to the 4th simplify to? Well, again, 4th root and 4th power are opposites of each other. We call them inverses. They undo each other. And so if you start with x, you get right back to x. So let's show all of our steps in simplifying the 5th root of 32x to the 45th. Make sure we see why each equation below is true. We will do that. Okay, so first thing we're going to do is separate this thing. There's a numerical part and there's a variable part, and we're going to split that up into two radicals. Remember, there's an implied multiplication in here, and so our product rule says you can split into 2. Now, the 5th root of 32 is something nice. You might happen to know the number, but even if you don't, you can go look on the chart. Perfect fifth powers, look for 32. At the far left, you'll find the answer is 2. 5th root of 32 is 2, plain 2, not 5th root of 2. Okay, so here's the magic. I'm going to take a look at this guy right here, and I'm going to rewrite it in a very particular way. 5th root of x to the 45th, that's what we're starting with. I'm going to write it this way. 5th root x, I'm going to put parentheses here. I'm going to put a blank box right here. And I'm going to put a 5th power here. And the reason I'm trying to force a 5th power up there is because that is a copy of this index right here. And so if I can force a 5th power here, then I know that the 5th root, the whole radical symbol, and the 5th power are opposites. They cancel each other, and I'll just be left with the much simpler x to whatever is in the box, and that'll be it with no radical anymore. So the question is, what number are we putting in that box? Well, this is one of our 5 properties for what to do with these two powers. X to a power, that's property 3. We know we multiply those powers. So I'm going to put something in the box so that when I multiply by 9, when I multiply by 5, I get 45. So the question is, what can we put in the box so that when we multiply by this 5, we get the same 45x as we had before? So I accidentally gave away the answer there, but hopefully you see why it is 9. So we still have x to the 45th, and then we get to do this marvelous canceling. The 5th root, including that whole radical symbol, and the 5th power are opposites, and we just get x to the 9th. And so that is our final answer there, just with a 2 in the front. 2x to the 9th is the simplified version of the 5th root of 32x to the 45th. Now, in number 4, some of you may have guessed there's a shortcut here involving division. So if you take a look at the original 45 and 5, what can we do with those two numbers to get the correct final power of 9? Well, we can divide them. 45 divided by 5. And that shortcut is valid, but don't use it yet. We'll use it officially next class, next lesson. But let's do all of the radical of a variable to a power problems by using the technique in the previous problem. So for all of the activities coming up and the rest of this demo, we're going to use that same technique. So let's try it here in number 5. 4th root of x to the 20. Let's give ourselves this setup. I'm going to put an x here. I'm going to put a box here. And I'm going to force a particular power right here. What power do I want to force here? Well, I just want to copy that index. So there's no question this is supposed to be a 4. That's what we're trying to force. And so what do we put in the box so that we still have x to the 20th? Well, again, we know we're supposed to multiply these two and try to get 20. So I guess that means it must be 5. And we still have x to the 20, but now we get to cancel. 4th root, including that radical sign, and 4th power cancel, and we just get our final answer, which is x to the 5th. Okay, part B, same deal, but let's separate this into two radicals first because there's a numerical part and a variable part. And I want to separate them because I kind of think about them differently. So the cube root of 64, that's a nice number, that's easy. Read your sheet if you want to, but it's just a plain 4 times. Now we got to set ourselves up for success. So x is going to be a blank box. I'm going to force a power of 3. That's a copy of the index. And we got to figure out what number to put in that blank box so that we still have x to the 27th. Again, it's multiplication. So we should see that the power that goes in that box is 9. 9 times 3 is still the same x to the 27 we had before. So then we're going to copy our 4, multiply by, because of all the hard work we did, we get to cancel that cube root and this third power, and we just get x to the 9th. So 4x to the 9th is it. Okay, number 6 says, let's simplify this thing. Cube root of 16x to the 4th times the cube root of 2x to the 19th. So this is tough. I think this is one of the toughest problems of the whole semester. So let's push through this thing. Okay, first of all, we're going to do something very difficult with these radicals. It's a challenging process we're going to go through here for this radical and for this radical. But we can actually smush them together and make a single radical by doing our product rule in the opposite direction from what we've normally done. Normally we take two things inside a radical that are multiplied and split it into two radicals multiplied. But we could go the other direction as well, and the other direction is useful for us because when we smush these together into a single radical, then we only have to do this hard process that we're about to do once, instead of doing the hard process on this one and separately on this one and probably again on the final radical. Let's just do the hard process once. The first step is to take those two tough radicals and make one tough radical. That way we only have to do the process once. Let's shuffle these things around in our mind. The 2 goes with the 16, so that's 32. X to the 4 times x to the 19th. That's one of our 5 properties. This is the first one where we add the powers. So we get x to the 23rd. Okay, so cube root of 32x to the 23rd. It is a hard process we're about to do, but at least it's only one hard process and not 2 or potentially 3. Okay, so what I like to do, it's actually not exactly the way that it's written here. So I'm going to split this thing up into 2 separate radicals. I'm going to split the numerical part off from the variable part, just like we did up above. So here are my 2 radicals. Number part split from the variable part. Okay, let's deal with the number part first. Okay, 32. Is the cube root of 32 a nice number? Not particularly. It's irrational. It's not in our perfect cubes column. So the best thing we can do in terms of simplifying is find a perfect cube that goes into 32. So looking at your perfect cubes list, you should see 1 and 8 and 27 and 64. Do any of those numbers go into 32? Yes, 8 goes into 32. So we rewrite 32 as 8 times whatever we need to still make 32. 8 times 4 in this case gives us 32. And let's keep going with this one. I know I've left the x to the 23rd out in the cold, but we'll come back to that one. So this one we can split up. Cube root of 8, cube root of 4, and then the cube root of 8 is a nice number. It is 2, and the cube root of 4 is irrational. It just stays right there. And those two things will be in our final answer, 2 and then a cube root of 4. Okay, let's work with the cube root of x to the 23rd. I'm going to change colors here just so we can distinguish. Okay, don't write this down because it's not going to work, but our typical plan at this moment is to do the following. I really want a third power up there. That's a copy of the index. So we put an x, and then we put a box, and we fill in a number in the box so that we still have the x to the 23rd that we had before. So the question is, what number can you put in this box right here so that when you multiply 3 by that number, you get the 23 x's that we had to start? And hopefully we see we've got a problem, right? Like 3 doesn't go evenly into 23. So if you're putting a number in this box, it's got to be a fraction. So it's not an integer like all the other ones we've done. So what can I do? Well, I have 23 x's to play with, and that was not a friendly number for us. In fact, we didn't really pay much attention to this before, but it was chosen very carefully, these powers up here. I chose very carefully 45 and 5 because 5 goes perfectly into 45. And the same thing was true, that 27 is divisible by 3, 20 is divisible by 4. But I didn't choose as nice a combination of numbers here. So we got to do some work. So the 23 x's we have to play with wasn't very friendly for us. So let's imagine peeling one of those off. You don't need to write this either, not yet. X to the 23rd is really x to the 22nd times x. Just peeling one of those x's off. So imagine for a moment that instead of x to the 23rd, this is really x to the 22nd, x to the 22nd. So can you put a number now in this box that when you do 3 times that number, you get 22? No, 22 is also not divisible by 3. So that wasn't very helpful. Let's go back and peel off another one of these x's. So I've got x to the 23rd. Let's think about x to the 21st, and then there's going to be 2 x's left over. So if up here it wasn't x to the 23rd, but rather was x to the 21st, could we deal with that? Could you put a number in the blank orange box that will give you a 21 after you multiply the blank box by the 3? Oh yeah, I could put a 7 right in there. Okay, finally we found our winner. X to the 21, that's the friendliest number of x's we can play with. That's less than or equal to 23. So go back to where we were, which was right here. I'm going to erase this guy. We weren't quite there. And we're going to rewrite x to the 23rd as x to the 21st times x squared. Do copy that. This is going to work for us. So we peeled off 2 of those x's because x to the 21st was something friendly for us. And this is always our process, is you peel off x's one at a time until you get something friendly, something where the power is divisible by the index. Okay, now we can split into 2 radicals, x to the 21, and then times cube root of x squared. I've got no space over here, gang. Cube root x to the 21, cube root x squared, maybe. Okay, I need to expand into the blank space here at the bottom. Okay, this is the part where we set ourselves up for success. X here, we're going to put a blank box. I'd really like a cube there, and then I'm copying the cube root of x squared. That's not going anywhere. That's going to be in the final answer. Blank box right here, hoping to put a number in the blank so that when I multiply by 3, I get the 21 x's I had. So we did this before. It's the number 7. That's what we put right here in the blank box. And then because we did all that hard work to get the cube root to match the 3rd power, we get to cancel cube root and 3rd power, and we're just left with x to the 7th. So our almost final answer, one step away from the final answer, is, so I'm copying the blue stuff, 2 times the 3rd root 4 times, and now I'm copying the green stuff. X to the 7th came outside, not in the radical anymore, but x squared is still inside the radical. And then our final answer is exactly this. We're just going to shuffle to the front all the things outside the radical. So that's a 2 and an x to the 7th. And then we're going to combine the 2 things in the radical into a single radical. So this is our product rule again. 2 radicals multiplied, you can smush together and make one single radical multiplication inside. So that is our final answer, 2x to the 7th times the cube root of 4x squared. In terms of these kinds of problems, this is as hard as they get, but I really want you to get to a place where you can solve problems like this. It's going to take practice. I'm not saying it's easy, but you can get good at this with some work.